In today's class, we are going to discuss about the quadratic formula, another method to solve a quadratic equation. We have already discussed about factorization method and the method of completing the square. These are the two methods. So quadratic formula, using quadratic formula is another method to solve a quadratic equation, and in my opinion, it is the easiest one. You just have to remember the formula, input the values, and you get the solution. So in today's class, we will see how the quadratic formula works and what are the things we need to keep in mind. Okay, so let us start. First, I will tell you what is the quadratic formula looks like. So this is how the quadratic formula looks like. So what is B, A and C? We have B, A and C. So what is this B, A and C? If you remember the standard form of a quadratic equation, it looks like this, right? So suppose there is a quadratic equation that looks like this. Okay, so this is a quadratic equation. It is in the standard form. So what is A here? Compare. A is equal to 1. What is B here? It is 5. What is C here? It is 6. So we get the values of A, B and C. So these are the A, B and C here. C. Okay. We get the values of B, A and C from the quadratic equation itself. A is the coefficient of x square, B is the coefficient of x, and C is the constant term. So input the values, you get the solution to the equation. So let me solve this equation to show you how the quadratic formula works. So here in this equation we have A equal to 1, B equal to 5, C equal to 6. So solving for x, we get x is equal to how much? Minus b. Minus b is minus 5. Then plus minus b square. B square is 25. 5 square is 25. 4ac. 4 into a into c. 4 into 1 into 6. 24. Divide by 2a. 2a is 2 into 1. 2. So we get minus 5 plus minus 25 minus 24 is 1 by 2. That is minus 5 plus minus 1. Square root of 1 is 1. 2. So we get minus 5 x equal to 2 or x equal to minus 5 minus 1 by 2, which implies x is minus 2 or x equal to minus 3, right? And this is the solution. So we get the solution or the values of x by just replacing the values like this from the equation itself. So it is very easy. You just have to remember the formula. Okay, and then input the values from the equation itself and you arrive at the solution. Much easier than doing factorization or using the completing the square method. So if the question does not mention that you have to use a particular method, then you can use the quadratic formula directly and arrive at the solution. You don't have to use factorization or completing the square method. Okay, but if it specifically says that you have to use Say suppose factorization, then you have to use factorization. You cannot use this quadratic formula. It depends on the question, basically. And now, a few important things you have to remember. We have this term b square minus 4ac. This is known as discriminant or D. It is called the discriminant of the equation. It is called discriminant because it distinguishes between different possible roots of an equation. So what does that mean? We know that a quadratic equation can have at the most two roots or two solutions, right? So the discriminant distinguishes between the type of roots, what type of solutions we will get. So the name discriminant, it distinguishes, it discriminates. Okay, let us understand with an example. So we already have this equation here. A is 1, B is 5, C is 6. So what is B square minus 4AC? It is 5 square, that is 25, minus 4AC is 24, it is 1, right? Which is greater than 0. That means the discriminant, this one, discriminant is greater than 0. When the discriminant is greater than 0, we have roots are real. We get real roots. How many? 2. And distinct. Real and distinct roots. Do you remember what we got earlier? Minus 5 minus 5, yes, minus 5 plus minus b square for 1 by 2. It was minus 2 and minus 3. Minus 2 and minus 3, the values of x or the roots of the equation, the solutions to the equation were minus 2 and minus 3. So when d is greater than 0, we get real roots, both are real, minus 2 and minus 3, both are real and both are distinct. We get two roots which are real and distinct roots. So every time you get greater than 0, for when you solve a quadratic equation, just experiment it yourself. Okay, just when the value comes as greater than 0, when the discriminant is greater than 0, you will always get real and distinct roots. Two roots, both are real and distinct. Condition is discriminant must be greater than 0. Okay, now let us take another example. Suppose x square minus 4x plus 4 equal to 0. Another quadratic equation in the standard form. So let us solve this equation. So what we get using the quadratic formula, minus b, what is minus b? Minus into minus, minus minus, minus b, plus minus, b square minus b square. 4ac is 4 into 1 into c divided by 2a minus 4 plus minus how much? 16 minus 16. 2a is how much? 2a is 1. So this 2 4 plus minus 16 minus 16 is 0 by 2. So 4 plus minus 0 by 2. So basically we get two solutions, 4 by 2, 4 by 2, 4 by 2, which is equal to 2, 2. So we get two solutions when from this equation we get two solutions which are equal. Let us find out the discriminant. b square minus 4ac. What is b square? Minus 4 square 16 minus 4ac is a into c, 4 into 4 16 again 0. So when the discriminant is 0, then we get two roots which are real, both are real and both are equal. So what do we get from here? It is that when the discriminant is equal to 0, then we get real roots and both are equal roots. When the discriminant is greater than 0, real and distinct. But when discriminant is 0, they are real and equal. That is the case. For all equations where the discriminant is 0, then the roots will be real and equal. Because ultimately we get the solution like this. That means this part will be similar in both the cases, in both the roots. So we get two real and equal roots. Okay? Now let us take another equation, 4x plus 5 equal to 0. This is in the standard form, quadratic equation. So let us first solve it using this formula. So what do we have? Minus b, which is minus 4, plus minus square root of b square. What is b square? 4 square 16. What is 4ac? 4 into 1 into 5, it is 20, divided by 2a. What is 2a? Equal to 2. So we get 4 plus minus root over minus 4. Okay. So this one will give us the roots. But what is minus 4? Square root of minus 4. A negative number has no real root, square root. Right? A negative number does not have real square roots. So this whole thing is not real. So the roots are not real. So we have imaginary roots. So what is the conclusion? If this number, the discriminant, is negative, let me explain it again. You see this number minus 4, we arrive it by this formula, discriminant b square minus 4ac. What is b square? It is 16. What is 4ac? It is 20. We get minus 4. So if it is minus 4, if it is negative, then we have to put it here, minus 4. So we get the square root of minus 4. But there cannot be any square root of a negative number. It is like this, square root of minus 4. It cannot have real, this number cannot have real square root, right? Because it is a negative number. So the whole thing is imaginary. So the roots are also imaginary. We have plus 4, minus 4 plus minus 4 by 2. The roots will be like this, minus 4 by 2. So the two roots are like this, but none of them are real. Both are imaginary. So we have imaginary roots. So when b is less than 0, then we have no real roots, right? When b is less than 0, then the equation cannot have real roots, because we are dealing with square root of a negative number here. B square minus 4ac is a negative number, so square root of this negative number is not real. So we have imaginary numbers, which means this equation has no real roots or no real solutions, right? I will explain this in more details. If you are interested, write to me. I will explain in details. Okay. So we have the quadratic formula like this. It is very easy to solve any quadratic equation with the quadratic formula. You just have to convert the equation to the standard form like this. Then find out the coefficient of x square, x and the constant term. Replace the values here and you get the solution. Okay. So if the equation does not say that you have to solve by a particular method, then you always use the quadratic formula for faster results. Okay, you will get the result very fast. You just replace the values, you will get the solution. Okay, and always remember the use of discriminant. Why discriminant is important? And if discriminant is 0, we get real and distinct roots. If it is it is greater than 0, then we have real and distinct roots. If it is equal to 0, then we have real and equal or repeating roots. And if it is negative, then we do not get any real solutions. Okay. So let us stop the class today.